Hello and welcome to a third video. We're going to be talking about test for proportion. Proportion means a ratio of something. If I have, for example, 200 students out of 700, so what would be the proportion out of the 200 versus the 700 is going to be 200 divided by 700. And as a result, I'll be able to figure that by using an Excel. So it's going to be, or any calculator, 200 divided by 700. So basically 28%, almost 28, almost 29% of the students are going to be, within certain, statement or behavior. Let's go ahead and make sure that that's really what the proportion means. So if we find that 39% of the United States households save money for their kids' college, this is basically what is going to be the proportion based on the study they have done before, taking it from the population, which is really everybody who lives in the United States, assumingly. So a random sample of 400 of household indicated that 234 have college saving of some sort. At this level, a level of 0.02, which means a confidence level of 98%, does this suggest that there is a difference of, that's a key word that we have to really be aware of, which means what? Is going to indicate not equal to from the null when I do the null hypothesis. So is it different from what was found before? All right, let's go ahead and state the facts, then we're going to form the whole thing because now we have to worry about a new formula that is different from calculating the z distribution and the t distribution. So the first of all, the 39% of the United States population who save for their kids is the 39 is going to be turned into p value in this formula here. See, this formula is going to be critical. And 0.3. So how we got to calculate the b hat, which is based on the sample, the proportion for the sample. It's going to be, this is b hat. I'm going to go ahead and put the little tiny, let me put the word hat next to it. B hat, not b hat. Here we go. B hat. Okay. And we're going to go ahead and that's going to come from those people who really do the saving out of a sample of 400. And the claim that these people actually suggest that they're different from the 400s. That's the claim. So we're going to go ahead and say, okay, 234 divided by 400, and that's going to give me my p hat. What is the q? The q is really what is left out of 1 when we say the probability of something is 0.39. That's mean the q, which is 1 minus p, as stated in this formula. In the book, you will see that 1 minus p is really mentioned as a q. It's the same thing, which is 1 minus p, which is 0.39. I'm not using Excel for the, as you see, like clicking on the cell address in order to reflect the change. So I'm using it as a calculator, just in case you don't want to use it. And this way, this is q, this is p hat, and this is, I know the n is going to be 400. So I'm ready to calculate the z, which is ironically, this is the z-score that we have also looked up in the table previously when we did the z distribution. But the formula to the, or equation to the right of the equal sign is going to require, of course, different calculation. We have to be very careful, especially when we use it in Excel, because the rule of order is way too important. So let's go ahead and look at the null hypothesis and look at alpha. And knowing that we're going to keep in mind this is two tails. The null hypothesis is mu, which is the mean of the population is equal to 0.39. The alternative hypothesis is mu is not equal to 0.39. It could, if we say less than, that's a different story. If we say greater than or not equal, those are the other three alternatives if it's not equal to. So in this case, we have not equal to, I'm using Excel notation, this is not equal to. And of course, in writing, you should do the equal with a little slash through it. And to continue with this, alpha is 0.02 at the confidence level of 98%. And of course, that's going to be divided into two critical region. Each one of them is going to be not 0.00, it's going to be 0.01, and this is 0.01. Okay, so before we actually allow ourselves to use the z-score, we have to pass a little tiny test. The first test tells me that the number in the sample, which is 400, multiplied by p, which is the 0.39, must be greater than 5. Some book ask you actually to verify it greater than 10. Okay, I haven't done a Roger study to understand the difference yet. So I'm going to go by our book and see if it's NP greater than 156 is definitely greater than 5, and 400 multiplied by the Q, which is more than the probability, which is 0.585. It's going to be definitely bigger than the 105. So those are both okay. So meaning we can use this formula in order to do the calculation to figure out what is my critical regions. In this case, I have to use regions, two of them. Anyway, for the critical region at 98 percent, and I have two regions. So I'm going to go ahead and use the Minitab to figure that out very quickly. And I'm going to go ahead to probability distribution. I'm going to do the view probability, and I'm going to leave it as normal now. Believe it or not, that's what we're going to use. That's what the Z is, normal. And 0.01 for the mean, 1 point for the standard deviation, the shaded area. I'm going to use both tails. It's easier. You could use the middle also as well, but you have to also divide that by 0.001. And it's going to reverse the color. It doesn't matter because you're going to get the same value either way. So I'm going to go ahead and choose this. It's a shortcut, 0.00, 0.02, not 0.00. And you click in here and take a note of what the value for the critical region, which is 2.33 and minus 2.33. So good. Let's go ahead and keep that. Minus 2.33. And let me make sure that also I chose the 98 because I don't know, I was documenting here quickly. I need to make sure that this is, okay, that's 0.02, that is 98, and here we go. So this is basically what is going to help me to figure out when I do the calculation. So let's go ahead and do the calculation here for the P calculation, which is going to now based on this formula. I'm going to go ahead and say P hat is 0.585. That is subtract B from it, 0.39. Okay, that is going to actually be divided with this one here, which is the P. Let me go ahead and do this. P, which is 0.39, minus the Q, which is 0.61. And the result of all that is going to be divided by square root of 400. I'm using more parentheses to avoid any complication here because the P multiplied by the Q, then after that we do the division of the whole thing. Let's go ahead and do that. Whoa, maybe something here wrong. We go ahead and do that. 0.85 minus 0.39. Oh, okay, obviously the P hat is 0.585. That's the P hat. Minus the P, that's good. Then we have the P, we have the square root for everything, not for this one here, no big deal. So that's why I suspected this value. It's going to be the square root of all this, square root of P minus, so the square root before every parentheses here, and basically the square root is going to end up, okay, 1 second here. There's a square root. Okay, open this square root, and we're going to go ahead and say P, which is that 3.9 multiplied by 0.61. That's the Q. The whole thing is divided by 400 after we find, and that is basically going to be the square root. And here we go. That's what it's going to be 0.995, which is almost 9. I mean, sorry, 8. If I wanted to go ahead and do this, basically, here we go. But I will leave it like this. And definitely this is greater than 0.233, which is going to be, if you notice here, greater than the critical region. So guess what? We're going to reject the null hypothesis, not fail to reject it. Reject the null hypothesis by saying that people actually different from the claim that 39% of the people say for their kids. We're going to go ahead and run that very quickly because this is tricky here because we're going to go ahead and use the graph. I'm sorry, the stat in order to do that basic statistic for the proportion, which is right here, one sample proportion. The very first thing that we need to do is to go ahead and make sure the summarize is 2, 3, 4 for the number of events. The number of trials is 400. The hypothesized proportion is 0.39. That's exactly what I want. The option is going to be 98%, and the proportion is not equal to. You're going to see it first exact, but you have to change it to a normal distribution or normal approximation because we passed the test of NP greater than 5 and NQ is greater than 5. And we should be getting the same, or if not to the exact, but very, very close value of P proportion. I'm sure you have figured out the P calculated is different than the P value, which is a whole different story. And here we go. The Z value is going to be 8, which is exactly what we did or calculated. It's supposed to be Z here, but that's the whole the name of it. It's called Z proportion or the calculated proportion, just to make sure. So this is supposed to be, if I recall, this is 8. Well, very, very well, exactly the same. Even though when I rounded this, obviously they did rounded it to 2 decimal points for us to get 8. And if I do that with Excel, you will see this is basically it's going to be rounded to 8 as well with 2 digits to the right of the decimal point, which is greater than 2.3. Also, I wanted to make sure that the B value, which is way too small, smaller than 0.01, which is the alpha or one side of the alpha or half an alpha or alpha divided by 2. That's really the probability of the rejection for one region. So both actually should be looked at. In this case, Z value is greater than 2.33 and B value is much smaller than 0.01. Therefore, we'll reject the null hypothesis. We'll reject the claim that for the sample, let's put it more directly and more clearly. We respect, according to our sample, that there is a difference from what was found. This is basically, you should take it directly from, we say reject the null hypothesis, and we will state there, reject the fact reject the fact that they are the same, so there is a difference from what was found. Okay? There is a difference from what we found before because we rejected that null hypothesis. It takes a little bit of tries, but it will come through. Thank you so much.